The biggest problem with coding agents today is that people usually use the same model for writing code and then verification or debugging it. So you have the same agent with two different roles. The biases that produce the bug in the first place gets preserved when the same model checks its own work. Now, software engineering figured this out a long time ago. Author and reviewers are different people for a reason, and that applies whether the author is human or a model. Just using more agents is not going to fix the problem. If the verifier reads the producer's conversation history, it's going to inherit the same framing and biases that made the bug look correct in the first place. For verification to actually catch anything, the verifier has to start from zero. That means no conversation history, no context from the producer, just the artifacts with the specs, and you want to let it do its thing. There is one more problem with coding agents today, and that is they are sequential in nature. The agent works through everything one step at a time. It reads the specs, writes the code, runs the test, writes the docs, which is sequential by design. But if you have really good specs out there, you can actually parallelize a lot of these steps. A lot of work doesn't actually depend on the previous step. Reviewing 4 files for a pull request, maybe translating one document into 4 different languages, or generating tests across 4 different modules. None of those needs to wait. You can run them in parallel and get the same work done in a fraction of time. Now, this does not just apply to coding. Most of the knowledge work needs verification. And also, you can have parallel tasks running at the same time. This is how this new multi-agent system from Minimax called Mavis works. And in this video, we're going to look at the different capabilities, and I'll walk you through a few really interesting demos where you can not only decompose your task into multiple different subtasks, but you can have an independent verification step that ensures that your agents are not making mistakes. So let me show you a practical example of this multi-agent system with a separate verification step, which can do adversarial reviews. So this is Minimax Agent. Minimax is the creator of M2.7, which is arguably one of the best open-weight agentic coding model. Minimax is also the kind sponsor of this video. They recently introduced their token plan that include all modality API subscription for their video, music, image generation, and more. You can get 12% off of their plan with the link in the description. This is a desktop application that you can download and install it on your local machine, and very similar to other desktop application, you can connect it to a folder and the agent is going to have access to it. Now with this new release, they have included some really interesting new agentic capabilities. So for example, the first one is that you can create a team of agents. So in this case, it ships with 3 agents: coder, verifier, and journal. If we look at the setting of this agent, so this is specifically designed for shipping and writing code. Okay, and with every agent, you can actually connect to it and talk to it through an external interface like Telegram, WeChat. So whenever you are creating a project, then you have the capability to either use a single agent or use a team of agent. And I'll show you, whenever you use a team of agent, there is this adversarial verification or review step, which ensures that all the research that is done by the team of agent is actually correct. We'll look at a practical example of that. Now, they also have shipped something called Mavis Agent, which is kind of an always-on agent or assistant that you can connect to from anywhere. This is going to become your personal assistant that lives on your device. Now, there are also 100+ skills that are available as a part of this local assistant, or you can bring in your own skills if you want, right? They also have scheduled tasks, so you can schedule tasks for that are going to repeat or be triggered at a specific time interval of your choosing. Now, let me show you how this adversarial review process in a multi-agent system could look like. So let me show you an example of how this works in practice. So in this case, we are providing it to do market research on the state of open weight models today. It's supposed to create a 15 slide presentation, and we are asking it to do research on architectural differences, price comparison, recent benchmarks, and where things are heading. Right now, I am asking it to do research on these models, which are independent tasks. So I can use parallel agents to basically perform the analysis independently for every model, or do the research and then combine the results for collective analysis, right? And I'm simply telling it to use the pre-built slide component. Okay, so just like other coding models, we can select the permission level. So we're going to just bypass everything so it doesn't have to ask us. And you can also attach files or photos or specific skills. Now, in this case, I think it's going to be able to select the appropriate skill for building the slides. So we'll just send this in and let's see what happens. Okay, so since we're using a team of agents, so I think it is looking up that specific skill. Now it's launching 4 parallel research agents, 1 per model, and it says that this is a deep research territory. So the team plan is the right call. So there is an orchestrator which looks at the user prompt, and based on that, it decides how many parallel agent it's going to need, and then it's building these agents, which you can actually see here. So there is a research agent for M2.7. There's a DeepSeek one, Quen, and for Gemma 4. All right, it actually gives you the visibility. So right now you can actually see that it created different sessions for different agents, right? So not only it created those multiple parallel agents, but you can go and see what exactly each of these agent is doing, which is pretty great. Okay, so something interesting. It says Quen research session crashed at startup. A session failed before even picking up the task. Other 3 sessions may have the same issue. I'm monitoring and will retry once current sessions complete. You can actually see that the Quen one did not run. I think it will be able to fix that. The other ones are running fine. Okay, so while we wait, DeepSeek research agent has completed a task, and you can actually see the research report that it has generated. So here's the technical information, key innovations. So the research phase is done, and then after the research phase, it actually created independent verifiers for all the claims. So this one is for the M2.7. Here it says verification completed. There seems to be an error or an issue that it couldn't verify some of the things, right? So it went back and redid the analysis, which is pretty great, right? Because like every step that you take actually is verified by an independent adversarial review agent. Now, the beauty is that it doesn't share the context of your agent that did the research. It knows the objective, and based on the objective, it looks at the research that was done independently and is able to highlight issues that probably are going to be missed if you use same agent for research and then verification with shared context. So by system design, I think it's a really neat idea to have this independence between the 2 steps. Now, once that is done, it created the slide deck for us. I'll show you that in a minute. But this is a really good example of the type of knowledge work you want your agents to do. So imagine instead of this, if it's your company data and you're doing some sort of report generation, you would use a very similar workflow. Okay, so here's the slide deck that it created. And by the way, it also generated this image in the background. So it seems like it has access to an image generation model. This is the table of content. So model overview, benchmark results, pricing, architecture comparison, and where things are heading. Now it generated multiple different files for each slide. didn't put together everything in a single slide or HTML file, but that's something we can easily fix. Also, I think if we prompt it based on the design system that we want, we are going to get much better results in terms of the visual output. But still, I think it's pretty good for the first pass, right? Here's kind of the pricing comparison of different models. I'm actually happy that it kind of highlighted that Minimax 2.7 uses a modified MIT license, right? So it is able to capture those nuances, along with that DeepSeek V4 Pro has this 75% discount on pricing at the moment. And in here, this is where key takes away and the future trends. Now, interestingly enough, it says MOE dominates cost versus performance, then agentic coding is the battleground. Open weight is not equal to free for commercial use, right? So it gives examples of M2.7 has a modified MIT license, so it's not non-commercial. Self-evolution is the next MOE. Context window hit 1 million context window. Propriety is not always better, right? I agree with most of the assessment that it has here. Okay, so it seems like the verifier actually found a factual error, and this is why you want to have this independent verification step. So this is in the pricing of how the report has priced M2.7, which is actually a very good catch. Okay, so this was a quick example of how you can use a multi-agent system that executes multiple different agents in parallel, and then the importance of adversarial review with an independent verifier. Now, there is one more interesting thing about this agent, and that is memory. Memory is a big thing right now. Everybody is trying to figure out what is the best way for the agent to preserve information. So in this case, what you can do is you can ask the agent to remember something, or it also automatically remembers the most important information. Now, there are 3 different types of memories. One is session memory, which basically is in context learning. The second one is agent memory. And this is, I think, a big thing. The way this works is that agent is going to look at a session and figure out what it has done and what are the most important things that it can write to its memory. So for example, here in this session, it says that the playwriting screenshot path restricts the team plan out of phase at 3 cycles. Okay, so this is something important that it can reuse, and that's why it wrote it to the agent memory. Then there is a third level, which is user memory, or let's call it global or permanent memory. So this is for task across user knowledge. Now, in this case, it wrote to the memory about the pricing. So I went to another session and I simply asked it, do you remember how cheap was M2.7 compared to Opus? So rather than going to the web and try to fetch that information, it is simply looking at its memory. So it says, based on my memory, I recall from the user profile that there was a research session, right? And then here's like how cheap it was relative to Opus, right? And this is important because not only the agent will be able to learn from its mistake, that is self-improvement in a way, through its agent memory, but it can also remember things across different sessions for you as a user. And this is becoming a very critical piece that most of these agentic systems still lacks. Now, Minimax Agent is a desktop application that you can run locally with your local file access. Okay, so here's the web version of the same agent. Now, the desktop application runs locally, has local file access, but this is more for a cloud hosted solution. And I was actually looking at it. So here they have Max Hermes, Max Claw, which is different than the Mavis assistant that we saw. These are the Minimax version of OpenClaw and Hermes Agent with all the different capabilities, but they are hosting the solution for you. So it's basically one-click deployment that you can use with the Minimax models with very similar capabilities to what you get out of OpenClaw or Hermes Agent. Now, I have personally used the Hermes Agent, and I think it's pretty good, especially its ability to self-evolve. So if you don't want to set it up locally, this is a really good option. to get started and get a feel of what the agent is able to do, because it lives in the cloud, so you don't even have to worry about setting it up on your local machine. You will need to give it access to the tools that you want it to use. Anyways, do check out Minimax Agent. Make sure to check out their token plan. You get 12% off with this unique link in the video description. Also, do let me know what type of agentic architectures that you have worked with. Have you found self-verification to be useful, or it's just an additional step in your experimentation? Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.